Good day, students. Today we're going to do the formal proof of TanChord Theorem. You will be given that AD is the tangent of the circle with center O, and you'll be required to prove that DAB, this angle, is equals to BCA. And how do we do that? We start by constructing a line that passes through the center. From point A, you construct a line from the point of contact of the tangent, and you connect that line with angle C. You are required to prove that DAB is equals to BCA. You are required to prove that DAB is equals to BCA. You're connecting that line to the angle at C because you are required to prove that angle at C is equals to this angle. Okay. From there, you can name this point K, or you can name it any variable that you want, and you must show that you constructed it. Construct AK and CK. Okay, let's move on. After constructing this line, you know that diameter, it is always perpendicular to the tangent, meaning that the angle that is formed here is 90 degrees. The angle that is formed by the line AD and AK, which is our diameter, is 90 degrees. So meaning we can name our angles at A because it forms a number of angles. We can name them. This one can be A1, this one can be A2. Pause. Okay, since I've already said that the angle that is formed by the diameter and the tangent at point of contact is 90 degrees, let's show it. A1 plus A2 is equals to 90 degrees. Tangent is perpendicular to diameter. So now we're gonna let X be equals to our A1. Therefore, our A2 will be equals to 90 minus X. So from there, then our A2 will be 90 minus X. Okay, let's write it down here, 90 minus X. So let's take a look at this line and the angle that is subtended by this line. So this is our diameter, and it also forms this angle here. And we know that angle in a semicircle is 90 degrees, or you can say angle subtended by diameter, it is always 90 degrees. Therefore, our C will also be equals to 90 degrees, angle in a semicircle. So we can see that there are two angles formed at angle C. So let's name them. Let's say this is C1 and this is C2. So if you take a look at this diagram, you can see that there is an angle here. Take a look at this arc KB. You can see that this arc subtend angle A2 and also angle C1. So meaning that angle C1 and angle A2 are gonna be equal. Why? Angles in a in the same segment because they are subtended by the same arc. So let's show that. Angle A2 is equals to C1 is equals to, remember that A2 is equals to 90 minus x. 90 minus x, raising angles in the same segment. Okay, since we have proven that A2 is equals to C1, therefore we can write this here 90 minus x. But remember that this angle C1 plus C2 as a whole is equals to 90. If this one is 90 minus x, it means that this one plus this one is equals to 90. So angle C is equals to 90 minus x 90 is equals to 90 minus x plus angle C2. We have proven this is equals to 90. So 90 is equals to 90 minus x because our C1 is 90 minus x and our C2 is what we are looking for. So C2 will be equals to 90 minus 90 plus x. Why 90 minus 90? When you take this, when you transpose this 90 to the other side, it becomes negative. Then when you transpose this negative x to the other side, it becomes positive. Therefore 90 minus 90 is the same as 0. Therefore C2 is equals to x. But what is C2? Oh, C2 is angle BCA. And remember we let A1 be equals to x. Therefore we have proven that C2 is equals to A1 is equals to x. And that is what we were required to prove. Therefore you can write that down as per required. DAB is equals to BCA. Thank you.